Okay guys, in this video we're going to talk about how we calculate the free energy change for a reaction. This is a concept map for whole chapter 17. And as we mentioned in our class, there are two ways to calculate the free energy change. The first one is based on the enthalpy change and the entropy change for the reaction. Right here, the blue equation. The second way is to calculate the free energy change based on the standard molar free energy for the products and the reactants, the second equation here. So in this problem, we're going to calculate the free energy change for this reaction from the two different ways. Okay, so let's see the first way. Calculate the free energy change based on the delta H and the delta S. The first thing is you need to, in order to find out the delta free energy change of the reaction, you do have to find out the enthalpy change for the reaction and the entropy change for the reaction separately. So here's what we're going to do. This is a calculation of the enthalpy change for the reaction. And in order to do this, we have to use this equation. Okay, this equation here. We have to deal with the two products first. You have 2 mole of the NO, that is 2 mole, times the corresponding delta H formation for NO, 91.3 kilojoule per mole. Alright, so this is the first product. The second product is oxygen. You have 1 mole oxygen, the coefficient is 1. Okay, times the corresponding delta HF for oxygen, it's 0. So it's 0 kilojoule per mole. Alright, these are the two products. And minus the reactants. You have only one reactant, 2 mole of NO2 times the corresponding delta HF for NO2, 33.2 kilojoule per mole. Okay. Again, please put the units when you do this, when you set up the equation. And if you do the calculation, you will get 116.2 kilojoule. Calculation is straightforward, but you just want to be careful, okay? Second item, the entropy change of the reaction. The equation we need here is this one. Again, we deal with the products first. 2 mole of the product, 2 mole of the NO. The corresponding delta, the corresponding S for NO is 210.8. 210.8. Oh, it's joule. Okay, be careful about that. Let me erase this. So it's joule per K per mole. Okay, plus 1 mole times the S for oxygen, it's 205.2 joule per K per mole. Alright, these are the two products. Minus 2 mole of NO2 times the S for NO2, 240.1. 240.1 joule per K per mole. Okay, so here's the equation, and if you do the calculation, it will give you 146.6 joule per K. Now we have delta H and delta S. Now the second step for this first method is delta G reaction equals to 116, okay, delta H minus T delta S. So delta H is 116.2 kilojoule. Remember, this one has a unit of kilojoule. This one has a unit of joule per K. In order to do the math, you have to make sure they have the same units. So here, let's convert this kilojoule to joule. All right, joule minus T, temperature in Kelvin. Since this is a standard condition, 298 Kelvin times the delta S for this reaction right here. So that is 146.6 joule per K. And if you do the math, that will give you 513.2 joule. Okay, this is the first way to calculate the free energy change for this reaction. The second way to do it is to use this equation. Okay, and here you have those delta GF for the three species. What you need to do is just put them in. So this is the first way. The second way, delta G for a reaction, that equals to, again we use this equation. So we use 2 mole. You deal with the products again. The delta GF for NO is 87.6 kilojoule per mole. Okay, plus 1 mole of the oxygen times the delta GF for oxygen, 0 kilojoule per mole, minus the 2 mole that now we are dealing with the reactants, 2 mole of the NO2 times the corresponding delta GF for NO2, that is a 51.3 kilojoule per mole. Alright, if you do the calculation, it will give you 72.6 kilojoule. And it literally, the values from the two methods should be the same. Okay. However, because of the data difference, the S and H here, the experiment won't be able to give us the best data, the ideal data. So that's why they are a little bit different, but they are close enough. Okay. And one last thing, if I want you to decide whether this reaction is spontaneous or not, based on the delta G free energy change of this reaction, now you can do it, because based on the two different methods, delta Gn, the delta G for this reaction is larger than 0. So this one is a non-spontaneous process, okay, non-spontaneous reaction. All right, I hope this one can show you the two different ways to calculate the free energy change. Let me know if you have any questions.